This one was sent to us by Sophie Shilubane. Thank you very much, Sophie. A big shout out to you and your friends who are watching Tenfold Live right now. Thank you for sending us your questions, guys. We're here to help you analyze them. Again, it's another question that comes from functions. It's very exciting because I know that this is one of the topics that give you guys a lot of problems. So let's see what is going on with this one. It says if f of x is negative x squared plus 4x plus 12, calculate the coordinates of the turning point, okay? So we did discuss that you can find the x coordinate at the turning point with negative b divided by 2a. This is the first method we used in the previous question. Let's use the alternative for this one. What is the alternative of finding the turning point? Remember, at the turning point, the graph is stationary. So we are looking for the derivative, okay? Find the derivative. The derivative of negative x squared will be negative 2x. The derivative of 4x will be 4. The derivative of a constant is 0. After finding the derivative, you need to equate the derivative to 0. It's going to give us negative 2x plus 4. And then from here, you need to find the value of x. Add 2x on both sides. I'm getting 2x is 4. When I divide both sides by 2, I'm ending up with an x value of x equal 2. It means at the turning point of this parabola, that has to be a set phase parabola. The x value at the top is definitely a 2. We don't know what the y corresponding value is going to be. It's easy to find it. Just take the 2 and substitute for the corresponding y value. So we're going to ask for f of 2, which is negative 2 squared plus 4 into 2 plus 12. So if you work this out, you've got a minus 4 here. You're going to have 4 times 2, which is 8, added to 12, that's 20. If you've got 20, you subtract 4, you're going to end up with 16. So which means the coordinates of the turning point are going to be 2 and 16. Now, if you've got that, this is just by the way. If you've got that and they ask you to convert your graph from the form ax squared plus bx plus c, right, and change it to the form a into x plus p squared plus q, you're actually set to do that. Why? Because you should know that P and Q will be coordinates of the turning point. So which means I will then have X, but remember if it's a plus on the drawing, it will have to be minus on the equation with a square. The Y coordinate is 16, so I'll actually have plus 16 there. And the A value is the same as the A value that you started with. What am I trying to do? I'm just trying to change negative x squared plus 4x plus 12 to that particular form. The A value on the original is minus 1, which means even here, you still have a minus outside. It's a technique that you can use to just convert from one form to the other form if you are ever asked to do that. The A value, you copy it exactly as you see it, then you take the coordinates of the turning point, you plug them for P and Q, you are set. Everything is fine. You're up and running parallel to yourself. Okay, let's move on quickly. The next one that we asked to work out is for which values of k will f of x, right, equals to k have two distinct roots. Now, let's think about what is going on here. Does this graph have distinct roots at the moment? Yes. If you try to find the x-intercepts of this particular graph, you'd get two x-intercepts. I think you guys need to understand that you can solve the problem algebraically and you can also solve the problem graphically. If you're going to solve it graphically, you would need to see how the graph looks, which is normally what they would ask after you have drawn your graph. So this is basically what the parabola we're currently discussing would look like, right? Very important to keep that in mind. Now, if it looks like that, we know that it's got a positive x value on the turning point, so it's turning somewhere here with 2 here, and it's got a y value of 16. At this moment, it does have two distinct roots. It's got a root here and a root here. If I want it not to have roots, I must just shift it down. How many times? I must shift it down 16 units. So if I move it down more than 16 units, the graph will eventually look something like this. And then if it becomes white, then it means it will have non-real roots. If you move it more than 16 times, okay? So these are the ideas that you can think about. If they started by saying f of x equals to k, you move k left, you get f of x minus k equals to 0. So that k tells you that if you put a plus number, it's going to be minus a positive, which will shift the graph a certain number of times. So these are some of the ideas that you guys have to keep in mind when you are dealing with graphs that are sketched and we start asking you about the nature of roots. It's about just shifting it up and down or left and right. Okay, cool. So now in this case, let me try and actually do this one algebraically, just for the sake of your revision. F of x equals to k, two distinct roots. Okay, what am I going to do? I'll say they said f of x equals to k. f of x is negative x squared plus 4x plus 12 equals to k. That's negative x squared plus 4x plus 12 minus k equals to 0. For nature of roots, we must find delta, which is b squared minus 4ac. My b is a 4 squared, my a is a negative 1, my c is all this that you see here. So 12 minus k will be c. You're sitting with 16 minus, and minus is plus 4 into 12 minus 4 into k. Yeah, that's actually minus k, right? Then you multiply yourself in, you get 16 plus 48 minus 4k as your delta. I trust your algebra, guys. You'll then end up with the sum of those two, which is going to give us a solution of 64 minus 4k. They set two distinct roots. That is only possible if your delta, okay, is greater than 0, not greater or equal to. And then you have minus 4k is greater than negative 64. Again, we're dividing both sides by negative 4, then your k will be less than 64 divided by 4, which gives you an answer of 16. This is how you would do the question algebraically if you had to do that. In closing, the last question is a brilliant question. Determine the maximum value of k, of h of x is 3 to the power f of x minus 12. Now, in order to answer this, you just simply try and look at what is going on. They want the maximum value. They want the maximum value for h of x if h is 3 to the power of f. Now, f of x is the parabola we've been working with. You will get the highest value of h if f is at its biggest possible value. All right? What do I mean by that? So you look at the graph of h, which is this one that I'm going to box now here. That's the graph that you're looking at. The highest possible value on this graph of f is 16. It happens when y is 16, okay? So if I take that 16 as the highest possible value, because all the other y values are smaller than 15. You've got 15s and 14s and 13s and so on and so on. The highest possible value is when y is 16. So I just have to take that y coordinate to the turning point and substitute as the highest possible. That's the maximum value of the graph of f, and put it where we see 3 to the power of f of x. Then this is actually going to give us an actual solution to the problem in literally 10 seconds. So we want highest value of h of x, it's 3 to the power f. We say the highest possible value of f is going to be 16, but there's a 12 there, all right? Then when you do 16 minus 12, you get 3 to the power 4. 3 to the power 4 is an awesome number, which is 81, and that is basically the highest possible value of h that you can get in this particular case.